Alright guys, welcome back to the second part of our video series here covering the end of the year assessment study guide units 5 through 9. So in the previous video I covered problems 1 through 16, so if you're interested in looking at answers for those, go ahead and view the previous video. This one will cover 17 through the end of the packet. So let's go ahead and get right to problem 17. Problem 17 is getting into the process of solving for logarithmic and exponential equations algebraically. So in problem 17, it says algebraically find the value for the variables in each question. Write the answers in exact form and in approximate form to 2 decimals. So what we need to do here is, in the process of solving, we're going to think reverse order of operations, or SADMEP. We want to get the variable by itself following this reverse order of operations. So in 17a, we have a variable that's in the exponent of an equation. So this is an exponential equation. What we want to do here is, again, thinking reverse order of operations, subtract 5 first from both sides. That would leave me with 4e to the x minus 2 power equal to 65. Then I want to go ahead and divide by 4. So this would give me e to the x minus 2 power equals 65 over 4. And if you want to simplify this, write this in an exact decimal, that's fine. But I'm going to leave it as a fraction for right now. From here, now we need to get the x, or the variable, out of the exponent. So because the variable is in the exponent, we want to use inverse relationships, or if this is an exponential equation, use a logarithmic equation. Logarithmic equation needs to be of the same base. So we're going to take the natural log of both sides. That's going to cancel out or eliminate the e, the exponential portion on the left side of the equation, and leave us with just x minus 2. So x minus 2 is going to equal now the natural log of 65 over 4. Again, natural log is just log base e. Now we need to add by 2. So x is the natural log of 65 over 4 plus 2. So we add 2 to both sides to get x by itself. So this would be the exact answer, and then the approximate answer for that would be taking the natural log of 65 divided by 4, and then adding 2. So this would be an approximate value of 4.79. Let's take a look at B. B is another exponential equation, and we can solve it in the same manner. So in this case, the first thing that we want to do here is subtract 27 from both sides. So that would give me 10 to the 2x power equal to 163. Now I'm already to the exponential portion of the equation here. So this 10 is the base, so I need to use a logarithm of base 10. That's what we call the common log. So that would eliminate the base 10 on the left, and then I would take the log base 10 of 163 on the right. And then finally I can get x by itself by dividing by 2. So the exact answer would be log base 10 of 163 over 2, which we can type into the calculator. And it would give us an approximate answer of 1.11. Taking a look at C. C is now a logarithmic equation. The thought process is still the same. So the first thing that we want to do here is, following a reverse order of operations, subtract 9 from both sides. So that would give me the negative 4 times the log of 2x equal to negative, sorry, let me make sure I get this one correctly, 3.6 minus 9, negative 5.4. Then we would want to divide by negative 4 on both sides to get rid of that coefficient. So the log base 10 of 2x is equal to 1.35. Now we need to get rid of the logarithm. So we want to use an exponential equation that has the same base. This is a common log, so it is a base 10. So then 2x equals 10 to the 1.35 power, because we're going to take both sides to the as a power of 10, and the logarithm will cancel out on the left. Now we can finally divide by 2, so x, the exact answer is 10 to the 1.35 power over 2. And we can go ahead and evaluate that in the calculator. 10 to the 1.35 power. Divide that by 2, and this would be approximately 11.19. So in each of these problems, we can follow the reverse order of operations to get x by itself, and then use our calculator to round. The same thing will be true about D. So in this case, I want to add the 5 to both sides. So this is going to leave me 3 times the natural log of x plus 4 equal to 8. And then I'm going to divide by 3. Again, if you wanted to simplify the way this is written, that's fine, but I'm just going to write it as 8 over 3 for now. Now, to get rid of the natural log, I need to use an exponential expression with the same base. A natural log, again, is log base e. So I'm going to take I'm going to take each side of the equation and make it a power of the base e. On the left side, the natural log and e would eliminate each other. On the right side, I'd have e to the 8/3 power. Then I would need to subtract 4, so this would be e to the 8/3 power minus 4. And again, we can go ahead and evaluate this in the calculator. So e is second and then the natural log. Make sure you close your parentheses to make sure that that 8/3 is the exponent for e. And then subtract 4, so this would be approximately 10.39. Now, when we get to problem E, some of the ideas are going to stay the same, but we're going to have to use some of our logarithmic properties here. So notice that there are multiple logarithms in this equation. What would be nice is a problem like F, if there were just logarithms everywhere. In this case, there are not. So what we want to do is ideally get our logarithms to the same side and any other value to the other side of the equation. So I'm going to add a log base 10 of x to both sides. So I'm still going to have log of x minus 5 on the left side, but now it's going to be plus log x. And then I'm going to add 2 to both sides, so it's going to equal 2. Now, because I have 2 logarithms over here on the left, I can use my logarithmic properties to combine them. Remember, if you are adding 2 logarithms, you can multiply their input values. And so this could be the same as log of x squared minus 15x. Here again, we would need to get rid of this logarithm. So now we're to the point where we have combined this to a single log. We want to get rid of the logarithm, so we want to use an exponential equation with the same base 10. So I would take each side as a power of the base 10. And so I would get x squared minus 15x, because the logarithms would eliminate each other. The log and base 10 would eliminate each other, equals 10 squared. I want to get that 10 squared to the other side of the equation, so I'm going to subtract it because this is quadratic, and also change it to 100. 10 squared is just 100. Now we want to solve this expression. We can solve this expression through factoring. So x squared minus 15x minus 100 will break down into x minus 20 and x plus 5. Set that equal to 0. So we're going to get 2 solutions here. If we set both factors equal to 0, we get x equals 20 and x equals negative 5. Now, we do have to double check this. Remember, logarithms cannot have a negative value as an input value. So if I were to take negative 5 and substitute it in here for x, this would be a negative input value for the logarithm, and so x equals negative 5 is actually an extraneous solution. So we need to double check these solutions because we created a quadratic equation. We need to double check these solutions. We can eliminate negative 5 right off of the bat because we know that this is a logarithm, so it cannot have a negative input value. I'm going to go ahead and skip down, or no, actually I'll just do the beginning. So log 20 minus 15 minus 2, and then take negative log of 20. Make sure these are the same values, and they are, so x equals 20 is our solution. Finally, in F kind of has the same concept. The first thing that we would want to do is to combine the natural logarithms on this side. So if we go ahead and we combine the natural logarithms, these logarithms are being subtracted from one another, so we would divide their input values. Now, if both sides of an equation have a logarithm or a logarithm of the same base, we can use the uniqueness property here to basically eliminate the logarithms. If I have two logarithms of the same base that are equal, their input values have to be equal. So I can leave this as just, or rewrite this as x minus 1 equals 3x. And then I can go ahead and solve by multiplying by 16, sorry, multiplying by 6, and then subtracting x, so negative 1 equals 17x, and then divide by 17, so x equals negative 1 over 17. If I wanted to round that, I could round that as well. Now, one thing that we do need to be careful of here is double checking the solution. So if I take the solution, it's a negative 1 over 17. If I go back to the original equation and I were to substitute in a negative 1 over 17 for x here, that would give me a negative input value for a logarithm. So this solution is actually going to be extraneous. So because the only solution is extraneous, this example actually has no solution. And if we check this, we can actually check this by graphing both sides of the equation. So I've done that here in Desmos. I can see that both of these two different graphs do not intersect. So I can zoom out a little bit further and see that they come very close to one another, but they never will intersect. So this makes sense when I take a look at the graph that there is no solution for this problem. Okay, let's go ahead and go on to the next. We are still solving equations here, and we're going to do this algebraically, but this time we are solving systems of equations. So we've moved units now and into systems of equations here in problem number 18. Remember, there's two ways to solve systems of equations. You can use the elimination method, or you can use the substitution method to do this algebraically for a two variable two equation system of equations here. And this first one, I'm definitely going to go ahead and do elimination, because I can see right away is if I add the first equation to the second equation, what I'm going to get is 5x. The y's will eliminate each other, equals 15. Then I can do a quick division. X equals 3. So x equals 3 is one of my solutions. I do need to find what y is going to be. So y, if I substitute x into either part of these, I would get 3 times 3 plus 4y equals 5. So 9 plus 4y equals 5. Subtract 1, or 9, 4y equals negative 4. Divide by 4, y equals negative 1. So my solution here is a point would be 3, negative 1. So if I were to graph these two lines, they would intersect at 3, negative 1. Let's go ahead and take a look at a different way to solve the second equation. I'm going to solve the second equation through substitution. So I'm going to do that by getting x by itself here. This may not be the easiest thing to do, but I just want to show you a separate method. So I'm going to divide by 2 here. So x equals negative 3 halves times y plus 17 over 2. Then I'm going to go ahead and take this x value, or what is equal to this x value, and substitute back into the second equation. So this would be 4 times negative 3 halves y plus 17 over 2 minus 5y equals 12. I would distribute this 4 here, which would give me negative 6y plus 34 minus 5y equals 12. Now I can combine my like terms, negative 11y, and at the same time I will subtract my negative 34 from both sides. And so this would give me a negative 22. Divide by negative 11, so y equals 2. Now I can take this 2 and substitute it back in here to go ahead and solve for x. So if I substitute back into 2, I would get x equals negative 3 plus 17 over 2. So x would equal, this would give me 11 over 2, or if you wrote that as a decimal, 5.5. So my answer here would be 11 over 2, or 5.5 would be fine, 2. So if I graphed that ordered pair, their intersection would be 11 over 2, 2. Okay, let's go ahead and take a look at C. So C, now we're dealing with three variables and three systems of equations. So what I want to do here is ideally break down these equations, which I'm going to letter A, B, and C, into a linear system with just two equations and two variables. So if I take a look at B and C already are simplified a little bit. They only have two variables. So what I'm going to do is use the elimination with just B and C. So I'm going to take B and multiply it by 4 and add that to C. And what we'll notice here is that when we do that, the y values are going to eliminate. And that would give us negative z equal to negative 3. Then I can solve for z, z equals 3. Now I can take this value for z and substitute it back into either the equation that I have for b, that I labeled as b, or the equation that I labeled as c, and solve for y. So negative 2y plus 3 times 3 equals 1. 3 times 3 is just 9. So negative 2 plus 9 equals 1. Negative 2y would equal negative 8 after I subtract 9 from both sides. And then y would equal 4. So now I know what z and y are. And so I can substitute both of those values back into the equation I labeled as A to figure out the solution for x. So that would be x plus 3 times y, which is 4, plus 2 times z, which is 3, equals 16. So I can combine my like terms here. X plus 3 times 4 is just 12. 2 times 3 is 6. So this would be x plus 18 equals 16. And then I can subtract 18 from both sides. So x equals negative 2 would be the value for that third variable. So I eliminated one of my variables, or it was already eliminated for me, did a two-system variable equation, and then just reverse substituted everything back in to be able to solve for individual variables. So my answer would be negative 2, 4, 3. Let's go ahead and take a look at D. In D, it's not quite as easy, because in D, all three of these variables have all three of these equations have three variables. So what I'm going to do is I'm going to pick two equations and use those two equations to eliminate one variable. The easiest thing would be to add A and C. So 5x minus 3y plus 2z equals 4. And negative 3x plus y minus 2z equals negative 12. If I combine these two, what happens is I get a 2x plus, or sorry, not 2x plus, I get a 2x minus 2y, z's eliminate, equals negative 8. This is good because I've worked from 3 variables now down to 2. So I'm going to put a star by this equation to know that I want to come back to it. Now, what I did was I eliminated the variable z by combining a and c. I'm going to combine two other equations to eliminate the variable z as well. So to do that, I'm going to go ahead and I'm going to double A. I'm going to take 2a and then add that to b. So if I double A and then add that to b, that's going to go ahead and give me 10x minus 6y plus 4z equals 8. And then b did not change. Negative 3x plus y minus 2z equals negative 12. Combine these two through addition. Oh, sorry, I wrote down c and not b. There we go. So b is negative 9x plus 5y minus 4z equal to negative 12. There we go. Now, this will get the z's to eliminate. So this would give me x minus y equals negative 4. So now what I can do is I can create a systems of equations using the two equations here that I have starred. So I'm going to create a new system, and this system is going to be a two-variable system. So what I did is I eliminated z, and now I can create a two-variable system here. And I can use the elimination method with this two variable system. So what I'm going to do is I'm going to I'm going to multiply the second equation by a negative 2. So that's going to give me negative 2x plus 2y equals 8. And then when I simplify this, we may notice something happens here. When I simplify this, everything gets eliminated. So I end up with 0 equals 0. Well, if this is the case, we have a dependent solution. We don't come to a solution, but we come to a statement that is true. And in this case, our solution is going to be all real numbers. Now, there's some stipulations to what those numbers, how those numbers could relate to one another. That's why it's called dependent, but all real numbers will end up being part of the solution. Let's take a look at some other systems of equations in problem number 19. So in problem number 19, we're working back again to a two variable system of equations, but now these are no longer linear. In this first example, I have a quadratic equation and a line. Now, the easiest way to do this is, in most cases, not all cases, but the easiest way to do this in most cases is through substitution. So get both equations equal to the same variable and then substitute. So the first equation here is equal to y. I need the second equation equal to y. So I'm going to add y to both sides and subtract 7 from both sides. So the second equation can be rewritten as 2x minus 7 equals y. Well, now I can set these two expressions, the first equation and this rewritten second equation, equal to one another. So 2x minus 7 is equal to x squared minus 2x minus 3. And this gives me an equation that I can solve. It's quadratic, so I want to make sure that it is equal to 0. So I'm going to subtract 2x from both sides. So that would give me x squared minus 4x. And then I'm going to add 7 to both sides, so plus 4. Now I can solve this equation by factoring, and this would factor into x minus 2 quantity squared. To solve this x minus 2 quantity squared, I could square root both sides. X equals 0, x minus 2 equals 0, so x equals 2. Then I can take this x equals 2 and substitute it right back in there for y. So I'm going to go ahead and just save some work and just do this on the calculator. So 2 times 2 minus 7 will give me y equals negative 3. So my solution then would be 2, negative 3. So this line in this quadratic equation would intersect at the point 2, negative 3. Taking a look at B, I still have a two variable linear system. This time I have a quadratic equation and a circle. So I can still follow through the same process. I can get them equal to the same variable and then solve for one another. In this case, it might be easiest to get x squared by itself. Might be the least amount of work that I have to do here. So for the first equation, I'm going to rewrite the first equation here first by subtracting y from both sides, and then multiplying by negative 2. So x squared equals, a positive 6 plus 2y. Then with the other equation, it's going to be easy here just to subtract y squared. So x equals 41 minus y squared. Now I can set these two things equal to one another. So 6 plus 2y equals 41 minus y squared. It's going to be quadratic again, so I want to make sure it equals 0. So y squared plus 2y minus 35 equals 0. This is a pretty quick factorization for us. So not x, sorry. Y plus 7 times y minus 5 equals 0. And then I can go ahead and get y by itself, set both of these equal to 0 to solve for y. So y equals negative 7 and y equals 5. So I'm going to have two solutions here. Both of these solutions are going to come with an x value. So to get that x value, I'm going to go ahead and go back in here, and I'm going to substitute. So let's start with negative 7. x squared would equal 6 plus 2 times negative 7. So x squared, let's go ahead and just do this on the calculator. X squared equals 6 plus 2 times negative 7 would be negative 8. And then if I solve for x here, I'd get the square root of negative 8, which is going to be an imaginary number. So what we know here is we've got an extraneous solution. The solution y equals negative 7 is going to be extraneous. I want to find what the solution for y equals 5 would be, so let's go ahead and do the same thing and substitute in using 5 for y. So x squared equals 6 plus 2 times 5. So x squared equals 16, and x equals plus or minus 4. So I actually do have two answers here. So though I solved for y first, I'm still going to have two answers. My answers are going to be 4, 5, and negative 4, 5. So maybe you solved this one a little bit different. Maybe you got y by itself and then solved for x. You would have got negative 4 and positive 4 first, and then you could substitute and get your y values of 5 and 5. If you solve for y first, you get an extraneous solution for y, and then y equals 5, which gives you two x solutions, and it's still two coordinates where these intersect. Let's do one more of these. So in problem C, y is already by itself here, so let me get y by itself in the first equation. So I'm going to subtract x squared, so y squared equals 16 minus x squared. Then when I take the square root of y, remember that's going to be plus or minus the square root of 16 minus x squared. So now I have two values for y, set them equal. X minus 4 equals plus or minus the square root of 16 minus x squared. In this case, I need to get rid of the square root, so I'm going to square both sides of the equation. So this would be x minus 4 quantity squared, and that would end up giving me 16 minus x squared. So simplifying, x squared minus 8x plus 16 equals 16 minus x squared. This again is quadratic, so get all of the values to the same side of the equation. 2x squared minus 8x equals 0. Here I can factor out a 2x, so 2x equals x minus 4. Or sorry, 2x times x minus 4 equals 0. So 2x equals 0, x minus 4 equals 0, x equals 0, and x equals 4. Then I can go ahead and substitute these back in. So I get, if I take this 0 and put it back into the equation there, I get 0 minus 4. So I would get 0, negative 4 as a solution. And if I take this 4 and put it back in there, I would get 0. So I get 4, 0 as a solution. So two solutions for this one as well. Moving into problem number 21, I see there's two 21s here. So, but the first problem 21 is taking us now into the new unit, sequences and series. Notice that these in our assessments, our online assessments, we split them up. We knew one was an arithmetic sequence, we knew the other was geometric sequence. Here, it's not split up, so we're going to have to decide which is which. So in problem 21, it says determine if the given sequence is arithmetic or geometric. If it is, identify the common difference or common ratio. So what we first want to do is take a look at terms. Remember, geometric sequences are a term is multiplied by the same value to get the next term, and so on and so forth. If you do an arithmetic sequence, is a term is added to one term, or a value is added to a term to get the next term, and so on and so forth. So I'm going to check for arithmetic first. So what number would add to from negative 5 to get to negative 2? If you said plus 3, you'd be correct. What number would add from 2 to get to negative 2 to get to 1? That's plus 3 again. From 1 to 4, we see that this is plus 3. So every time we go from one term to the next here, we're seeing that we're adding 3 each time. So this is an arithmetic sequence. And it has a common difference of 3. We can do the same thing in the second one. So this one's a little bit harder. If you need your calculator, that's definitely okay. So if I wanted to figure out what's being added, I would take 3 minus 1/2 and see that I'm adding 2.5 to get to the one term to the next. Then if I take 11 halves minus 3, I added 2.5 again. If I take 8 minus 11 halves, I added 2.5 again. And then finally, if I take 21 halves minus 8, I added 2.5. So this one is also arithmetic. This one has a common difference of 2.5. And the next one, let's check for arithmetic sequence again first. So what was added from 1/2 to get to 1/4? A negative 0.25. So this is showing a negative difference here. What is added to get from 1/8 or from 1/4 to 1/8? This would be a negative 1.25. So we can stop here right now because the two numbers aren't the same. So there's not a common number that we're adding from one term to get to the next. Let's try multiplying. So if I wanted to see what might be multiplying here, 1/4 divided by, making sure I put parentheses around 1/2, I would be dividing by here, or sorry, multiplying here by 1/2. And then if I look the same between 1/4 and 1/8, I'd be multiplying by 1/2. And then I'd be multiplying by 1/2. So this one is actually geometric. And it has a ratio of 1/2, or 0.5. Taking a look at 21, the second 21, we again have to identify whether it's arithmetic or geometric. So first I'm going to check to see if it's arithmetic. It says to find the 10th term. So we need to know what type of sequence this is. So if I'm going to check to see if it's arithmetic or geometric here, first I see that I'm adding 0.15 here, and if you need to use your calculator, that's fine. And then I'm adding 0.15 there. So this is following an arithmetic sequence. Those are the only terms we have to check, but that's enough. To find the 10th term, remember, to find the nth term of a sequence, we take the first term, so 5.1, plus the common difference. Our common difference is 0.15 times n minus 1. And so if we want the 10th one, this would be 10 minus 1. So we can do this in our calculator. This would be 5.1 plus 0.15 to the times 9. And so the 10th term, a sub 10 is the 10th term, would be 6.45. We can do the same thing for B. So for B here, I might check and see that, okay, this is not arithmetic, because if I take a negative 243 minus 729, it has a difference of 927. But then if I take 81 minus negative 243, it has a difference of positive 324. So that's not going to be it. But I may notice here that this is a geometric sequence, and that geometric difference here is that we are multiplying by a negative 1/3. So this is a multiplication here every time by negative 1/3. So this is geometric. So to find the 10th term of a geometric series, we again start with the first term. So the first term is 729. And we take that term and multiply by the common ratio, negative 1/3, to the n minus 1 power, or the 10 minus 1 power. So we can do this again in our calculator, 729 times 1/3. Sorry, let's make sure this is a negative 1/3. It's going to make a difference to the 9th power. And we should get this decimal approximation Let's go ahead and put this into a fraction, and that fraction would be -1 over 27. So the 10th term here for b is going to be -1 over 27. So it's important to determine whether it's geometric or arithmetic first before trying to figure out what the term is. Looking at problem 22, we are evaluating partial sums. So that's what this capital S means. It means series of partial sums. So we're adding together the values from the series. Or the sequence. So this should be a comma here, a little mistake there in the writing. But this is -12, then -9.5, and then -7. So what we see here is that we are adding 2.5 to each term. So this is an arithmetic sequence. We're trying to find the series for 15, the first, or what the value will be if we take the first 15 terms and we add them all together. So in order to do this, we have a formula. That formula is the number of terms, which in this case there's 15 of them, times the first term, which is -12, plus the 15th term divided by 2. Basically, you take 15 times the average of the first and last terms. Now, what we don't know is the 15th term here. So in order to do the 15th term, we have to do what we did here in 21a. So a sub 15, the 15th term, is going to be -12 plus 2.5 times 14. So you could substitute that into the fraction if you wanted to. But I could also do this separate and then put in the answer. So -12 plus 2.5 times 14. And so the series is going to be 15 times -12 plus 23 over 2. So 23 is the value of the 15th term. So I can do this in the calculator. 15 times -12 plus 23 divided by 2, close my parentheses, and this series is going to have a value of 82.5. Taking a look at problem B. This time it was written as a series. If I tried to find out if this is arithmetic, I would see that I'm adding 4 here and then adding 12, so that's not arithmetic. But if I try to see if it's geometric, I multiplied by 3 there, and then I multiplied by 3 there. So this is geometric with a common difference, or sorry, a common ratio of 3. So to find the ninth, or the sum of the first 9 terms in the series, we have a formula for this as well. It is the first term, which is 2, times the quantity 1 minus our ratio, common ratio 3, to the nth power, which is 9. And then this is divided by 1 minus the common ratio. So I'm going to simplify this a little bit at a time. I'm going to take 1 minus 3 to the 9th. So this would be 2 times -19,682 all over 1 minus 3, which is -2. So basically I can divide this by -1. If I simplify 2 divided by -2, my series would be 19,682. So the sum of the first 9 terms would be this value. Taking a look at problem number 23, now we go ahead and we get into some probability and statistics. So we're moving units yet again here. In this question problem 23, it's asking about the probability of, we need to find the probability that event 1 and event 2 occur. We don't know what event 1 and event 2 are, but we do know some information about them. So we had an equation for the probability for non-exclusive events. And I'll go ahead and write out this entire equation. So the probability for an event 1 or an event 2 occurring is the same as the probability for event 1 occurring plus the probability for event 2 occurring minus the probability for event 1 and event 2 occurring. So what I can do here is substitute in the information that I know. So I know that the probability for event 1 and 2 occurring is 5 over 6. I know the probability for event 1 occurring is 3, looks like a 3 over 8. I know the probability for event 2 occurring is 3 over 4. What I don't know is the probability for event 1 and event 2 occurring. So I can solve for this. How I can solve for this is by moving my like terms to the other side of the equation. So I can do this in the calculator, and I'll go ahead and do that. 5/6 minus 3/8, and I would also subtract 3/4. And I'm going to go ahead and put this into a fraction for now. Come back to that later. So the fraction -7 over 24 is equal to negative p probability of event 1 and event 2. Because remember, this was subtracted, probability of event 1 and event 2. So now I can divide by -1. So the probability of event 1 and event 2 occurring is 7 out of 24. We will go with kind of the common expression that we have with assessments and give that in a decimal round or a percentage rounded to 2 decimals. So this would be approximately 29.17%. So we'll see all answers in our assessments as percentages. Taking a look at problem number 24. It says, if a restaurant is chosen at random in Rhinebeck, then there is an 84% chance that it is open on a Sunday and a 42% chance that it is open on a Monday. If there is a 96% chance that it is open on either Sunday or Monday, what is the probability that is open both days? So this is kind of like the last problem. Event 1 is, let's label event 1 is open on Sunday, and event 2 is open on Monday. So going back to this expression, we can use this same formula here. The probability that event 1 or event 2, so it's open on Sunday or it's open on Monday, is a 96% chance. The probability of event 1 that it is open on Sunday is an 84% chance. The probability of event 2 that it is open on Monday is a 42% chance. So we want to find the probability that it's on both days. So this is basically the same problem as the previous, but put into a word problem. So 0.96 minus 0.84 minus 0.42, and this would be negative 0.3 equals the probability, the opposite probability of event 1 and event 2 occurring. So now we can divide by -1, and see that it's a 0.3 chance or 30% chance that it is open on both days. Problem 25 says a die is rolled 3 times and a curious pattern emerges. On the first roll, the number is greater than 3. On the second roll, the number is greater than 4. On the third roll, the number is greater than 5. If all 3 rolls are independent, what is the probability that this occurs? So what we have here is multiple trials that do not relate to one another. So if we want to find the probability that we're going to have 3 rolls and it's going to occur in this exact pattern, what we need to do is find the probability of each trial and multiply them together, or each event. So the probability of the first roll is the number is greater than 3. So on a regular die, you have 3 numbers that are greater than 3. 4, 5, and 6. So you have a 3 out of 6, or a 1/2 chance of rolling a number greater than 3 on the first roll. We're going to multiply that by the probability of getting a number greater than 4. So you have a 2 out of 6 chance of getting a number greater than 4 on the second roll. You could get a 4 or a 5. On the third roll, the number is greater than 5, so you have a 1 out of 6 chance of this occurring. So if events are independent, we can multiply the probability of each one of those independent events to get the probability of the total sequence occurring. And so this would be 3 divided by 6 times 2 divided by 6 times 1 divided by 6. And we're going to go ahead and put this again in percentages. So this would be approximately 2.78% chance that you'd get a number greater than 3, followed by a number greater than 4, followed by a number greater than 5. Let's go ahead and take a look at problem number 26. So problem number 26, it says, there are 9 total children who range in age from 3 years old to 11. Their names, genders, and ages are shown below, arranged in alphabetical order. Answer the following questions. A, if a child is chosen at random, what is the probability they are a girl? So some important things to note about the table. There are 9 total children that are listed. 5 of these are boys. 4 of these are girls. Sorry, got that backwards. 4 of these are boys, 5 of these are girls. So if we want the probability that we're going to choose a girl, if there are 9 total, remember that probability is the probability of an event is the probability or the number of elements in the event over the number of elements in the sample. So the event is girls. There are 5 girls. The sample is the total kids. There are 9 kids. And so if we want to go ahead and put this into a percentage, 5 divided by 9, it would be approximately 55.56% chance of drawing a girl, choosing a girl. B says, what is the probability that a girl chosen at random will have a name beginning with an E given that they are a girl? So this is conditional probability. So given that they are a girl, that is going to be event 1. The name begins with an E, that's going to be event 2. So what we want is the probability of event 2 given event 1, which is the probability that event 2 and event 1 occur divided by the probability that event 1 occurs. So notice in the list, we already found the probability of event 1. Probability of event 1 occurring is 5 out of 9. The probability that event 2 and event 1 occurs, so that we choose a girl and that girl starts with a name starts with an E, are the 2 girls that have a name that starts with an E out of our no our sorry out of our 9 total individuals that we're choosing from. So if we simplify this, multiply by the reciprocal of the denominator, this would end up being 2 over 5 or 40%. Another way to do this is by simple quick counting. So if it says that we are given, if it's given that we are a girl, we have now eliminated all the boys from the conversation. So instead of having 9 in the sample space, if it says given they're a girl, now we are looking at 5 individuals. 2 of those have a name with an E, and so you could do a quick count to get 2 over 5 as well. The last question, C, says if if a child is chosen at random, what is the probability that they are either a girl or older than 6? So let's let event 1 be that it's a girl, and event 2 that it's be that we're choosing someone older than 6. What we can do is a probability of non-exclusive events here. So we have some overlap. We have some girls that are older than 6. So we can use the probability that event 1 or event 2 occurs. So the probability of event 1 occurs, that we have a girl, we already know this is 5 over 9. The probability that event 2 occurs is, event 2 is again that we have an individual that is older than 6. And so we have 5 individuals that are older than 6. So the probability that event 2 occurs would be 5 over 9. Now we can subtract the probability that both of these two things occur. So how many girls do we have that are older than 6? So we have Rosie, Elliot, and Evie. So we have 3 girls that are older than 6. We can subtract the probability that they would be both a girl and older than 6. So if we find this probability, this would be 5 over 9. Sorry, not 5 over 9. This would actually be 7 over 9. So what we could do here then is take 7 divided by 9, and this would be approximately 77.78% chance that if we chose one person at random, they would be either a girl or someone that is older than 6. Let's go ahead and take a look at problem number 27. Problem 27 said a local PTA member, at a local PTA meeting, a sample of parents were surveyed to determine how many children they currently had attending school. The results are shown in the frequency table below. So in the first question, we want to determine the mean, median, and standard deviation for this sample. Notice this word sample. So we want to hit the statistics key. We want to go to edit. We want to make sure that we clear out everything that's in there, and we want to enter our list. There we have it. So this is a 2-variable statistics list here because we have 2 columns with 2 values of information. So we want to make sure our list here matches up with our list there, and it does. So now we can hit the stat key, we can calculate, we can do a 2-variable statistic, and then we can hit enter here. Now, what we can find right off the bat is we can find the mean. The mean is x bar. So x bar is approximately, let's go ahead and round it to 2 decimals, 3.67. So on average, a household has 3.67 children. The mode is going to take a little bit more work for us to understand. So what we know here is that the sum of the y's, if we take a look at the sum of the y's, we can see here there's 55 families. The mode, or sorry, not the mode, but the median is going to be the number that lies directly in the middle if we laid out 16 ones, and then 24 twos, and then 8 threes, 3 fours, 2 fives, 2 sevens. So if we think about this, if we start on each end, there's 55. We're going to hit the 27 in one half number right there. Is going to be our median position, and so that's going to fall in the twos. So you could write out all the terms and find it by hand, but if we think about it a little bit conceptually, we'll find out, whoops, the median is the twos. Now, standard deviation for this problem is where a lot of people might mess up. Notice this says it's sample. So if it says sample, we need the sample standard deviation. So the sample standard deviation is capital S of X. So the sample standard deviation here is approximately 2.16. We use the sample because we're not surveying every parent in the school or at the meeting. Sorry, we're only surveying parents that are at the meeting, not all the parents that are at the school. So approximately 2.16 would be our sample standard deviation. In the second part, it says determine how many of the 55 families surveyed have a number of children that is within 1 standard deviation of the mean. Show your analysis. So what we need to do here is find out what numbers are representative of 1 standard deviation from the mean, either above or below. So we can do that by taking the standard, or our mean, 3.67, and then subtracting our standard deviation, 2.16. And so we're looking at numbers between, we're looking at numbers here that are going to lie between 1.51, and that would be the lower bound, and 3.67 plus our standard deviation of 2.16, 5.83. So basically we're looking at this group. Sorry, I excluded one there that I need. We're looking at this group. So it says determine how many of the 55 families surveyed. So we have 24 of the 2s are with 1 standard deviation, 8 of the 3s, 3 of the 4s, and 2 of the 5s. So 37 families are within 1 standard deviation of the mean. Taking a look at problem number 28. Problem 28 says the scores on a standardized test that Jeremy took were normally distributed with a mean of 82 and a standard deviation of 5. On the test, Jeremy scored a 90. What percent of students scored better than Jeremy did on this test? So what we can do here is we can attack this a number of different ways, but let's go ahead and just find the most efficient method, and let's use the calculator. So the mean for this is 82. And if I draw kind of a rough sketch here of a normal distribution curve, Jeremy's score is here at 90. We want to find the percentage that is greater than him. So what we can do here is we can use the normal CDF button on the calculator. So we'll hit the stat key, or sorry, second, and then the variable stat key bars, go down to the normal CDF for distribution. We need first to input our lower bound. Our lower bound is going to be Jeremy's score, 90. Then we need to input our upper bound. So we don't know exactly what the highest score would be, so let's just put in a drastically large number. I went ahead and used 10,000. Then we need the mean, which is 82. And then we need the standard deviation, which is 5. Then we can calculate this. This gives us the decimal approximation. So approximately 5.48% of students scored better than Jeremy on this standard test. If Lisa took the same test at a different time, and the scores were again normally distributed, but now with a different mean, 83, and a standard deviation of 6.4, then what score to the nearest integer would make her percentile rank the same as Jeremy's? So we need to figure out the percentile that Lisa is going to be in here. So I'm going to show you the quick way to do this here. What we know is that 5.48% of people scored better than Jeremy. So that means 100 minus this value. So 100 minus approximately 5.48 scored worse than he did. So his percentile is the 94.52 percentile. So there's a couple different ways that we can find this. The quickest way in the calculator is to use a button that we call the inverse normal button. Sorry, I can't talk and write at the same time. So this is, if we hit the second variable statistics to go to distribution, we go down here to number 3. This, the inverse normal distribution here, button number 3, allows us to put in a percentile, 94.52. And this is going to give us a corresponding z-score. Sorry, I need to change this decimal to a percentage. So let's go ahead and go back and change this, or sorry, this percentage to a decimal. So 94.52 should actually be 0.9452. And then that's going to give us a z-score. So the z-score for this, let's go ahead and round this to 2 decimals. It's going to be approximately a z-score of 1.6. So what this is going to allow us, we can use the z-score formula to actually find Lisa's data point. So remember, z-score 1.6 is equal to the data point minus the mean, 83, divided by the standard deviation of 6.4. So we can multiply both sides by 6.4. So I'm going to round it when I write it down, but I'm going to keep this number in my calculator. So 10.24 equals approximately x sub I minus 83, and then add by 83. And so this is going to be the score that would get her in the same percentile rank as Jeremy. It did say that we wanted to go ahead and round to the nearest integer here in the directions. So she would need to score, her score would need to be a 93. So if she scored a 93 with these new statistics, where Jeremy scored a 90 with the older statistics, then they would be in the same percentile rank. So the quick way to do this, if you know a percentile and you want to find the z-score, is to use the inverse normal distribution key. You can type in the percentile rank, and that's going to give you the z-score. Let's go ahead and take a look at problem 29. Now, problem 29 is giving us word problems going back a little bit. So this is not just about probability any longer. These are word problems that could represent any section, units 5 through 9. So 29 says, over a 14-year period, the balance of payments, deficit versus surplus, for a county government was modeled by the function f of x equals 1/4 x to the fourth minus 6x cubed plus 42x squared minus 72x minus 64, where x equals 0 corresponds to 1990 and f of x is the deficit or surplus in thousands of dollars. In part A, it says to sketch a graph to represent the function. So what we can do here is we can go ahead and type this information, this function, into the calculator and use the calculator to sketch a graph. So I have the function in there. I'm going to go to the window and I'm going to set my window to represent what we want. So this is over a 14-year period. So I'm going to start with x min equals 0, x max equals 14. If you wanted to stretch it out to 15 to get a little bit further, you can. And I'm going to hit zoom, and then go down to 0 for zoom fit. And then I'm going to fit the graph, and then I can sketch the graph, making sure that we label axes as we go along. So here I have my graph and representation. It's not perfect, but it gives me a good idea of what the picture looks like. Notice I put in, again, labels for the x and y axis. I put in some numbers like the minimum and maximum point on my y-axis and my minimum and maximum point on my x-axis. In B, it says find the years when the country broke even. So we know those years when the country broke even, or sorry, the county broke even. Those are going to be the x-intercepts. So we can find x-intercepts by looking on the table if they're going to be if they are going to be perfect integers. We can find them on the table. Otherwise, we can hit second, calc, and then we can hit the button for 0. It's going to ask for a left bound. So we're going to go ahead and move this cursor over here so that it's on the left side of the point that we're looking for. Hit enter. It's going to ask for a right bound. I'm going to go ahead and move it to the right side. Hit enter. It's going to ask me to guess. I'm not going to guess, and just hit enter. So this is going to be at x equals 4. So I'm just going to go ahead and put a 4 down here on the x-axis. And then do the same thing for the other point. So move this over to the right. Let's try this again. So second trace 0, move it over to the right, left bound, make sure I'm the left on the left side of that 0, move it to the right side, and then it's going to give me another 0, which is 8 here. And then the last one is not going to be an integer, so this is one that you would have to find using this method. So get a left bound, get a right bound, and this one's going to be about 12.63. So my work here is just labeling the points on the graph. So find the years when the country broke even. So this would be 4 years after 1990, so 1994. 8 years, 1998. And then approximately 12.63. So during, let's say, and during 2002, because it wasn't quite to 2003. It says list the years when the deficit level was $84,000. So this $84,000 is going to be the balance. It's a deficit, so we're looking for a negative value. So what we want to do here is hit the y equals button and put in negative 84. Remember, the y-axis is already in thousands. So we want to find these intersection points. We can do that by hitting second, trace, intersect, and moving to close to the intersection that we want. So it says first curve. So I'm going to move this all the way over there. You can't hardly see. There's one behind these numbering. So I'm going to move it over close to the intersection, hit enter. It's going to move it to the second curve, hit enter. It says guess, and I'm going to hit enter again. And there it gives me an intersection here. So this is going to be approximately 0.34, negative 84. And then we're going to keep doing that for all of the other intersections. So I went ahead and found all those intersection points and put them in there. So list the years when the deficit level was $84,000. So this first year, or this one is going to be before 1991. So this is going to be during 1990. Then 2 years after 1990 at 1992. Then 10 years after 1990, 2000. And 11.66, so and during 2001. Finally, in D, it says determine the greatest deficit that was reached by the county government. What year did it happen? So the greatest deficit is going to be down here in our minimum points on our graph. So to find those, we hit second, trace. We can hit this button 3, minimum. It'll say left bound. So it looks like I have a minimum over here. So I'm going to move to the left. That's again down under there. I want to find what this point could be here. So I'm going to move it to the left over there. I'm going to hit enter. Make sure it's on the left of that curve. And then I'm going to move it to the right of that curve. I'm not sure which one of these is the actual minimum, but I'm going to find out. And then hit enter to the right of this. So here's a point right here. So this is approximately 1.0, negative 100. And if I do the same thing with the other curve down over here, I'm going to get approximately 10.90, negative 100. So it said determine the greatest deficit that was reached by the county government. So this would be a negative or a 100,000. Remember the Y values is in thousands, so $100,000 deficit. And this happened twice. So during 1991 and during 2000. So it happened 2 different times based on those data points. Let's go ahead and take a look at problem number 30. Problem number 30 is also another one about using a graph here. So a farmer wants to stock a private pond with catfish. An environmental specialist determines that the pond supports a maximum population of 750 fish with growth modeled by the function P of t, where P of t gives the current populations after 2 months. Using a graphing utility, use a graphing utility to sketch the function representing the population of catfish in relation to months. So again, we want to go ahead and go to the y equals button and put in our function. So I went ahead and put in the function. I'm going to go ahead and set up my window. I'm not exactly sure what I should scale this out to, so I'm just going to go start at month 0 and go up to 100 months on the x-axis. And then I'm going to zoom and fit it, and then that's going to give me a picture where I can sketch my graph. So there I have a representation of the graph. Again, not perfect, rough sketch. Got some labeled points there. Part B says, how many catfish did the farmer initially put in the lake? So this is going to be our y-intercept. So this is actually really quick to find. If I hit second trace, I can type in any x value, and I can type in a 0. So when x is 0, that's my y-intercept. It's going to be 30. So how many fish did the farmer put in initially? So initially 30 fish. How many fish are there after 3 months? I can do the same thing. Second trace value. Now I'm looking for an x value of 3. So I can find 3 months on here. And this would correspond to the point. I'm going to put the point down because that's essentially my work. 3 and then 37.19. So we can't have a part of a fish. So 37 fish after 3 months. Finally, part C says how many months until the population will reach 300 fish. So again, this is a y value for the population. So I can put in y equals 300 and then graph the intersection. So second trace intersection, move it close, move my cursor over there close to the intersection on one curve, hit enter, it jumps to the other curve, hit enter, we don't need to guess, and it's going to put it on the map there for me on the curve, and so this is going to be approximately 36.97 300. So 36.97 months would be okay. If you went ahead and round this up to 37 months, I would take that as well. or something towards the end of the 36 month. Let's go ahead and look at problem number 31. It says the temperature in Fahrenheit at a given altitude is modeled by f of x, where f of x represents the temperature with respect to the altitude in thousands of feet. Find the inverse of f of x and state what the independent and dependent variables mean. So the inverse of f of x, we would want to switch x and y. We had some examples of this earlier. We'd want to, in earlier notes, we'd want to switch x and y and then solve for y. So the first thing that we would do here is subtract 59. So negative 59 equals negative 7 over 2y. Sorry, negative 59x equals negative 7. Sorry, all over the place here. X minus 59, there we go, equals negative 7 over 2y. And then we would divide by negative 7 over 2 or multiply by negative 2 over 7. So negative 59 times negative 2 over 7 is this decimal. Let's go ahead and make that a fraction. So this would be negative 2/7 x plus 1/18 over 7 equals y, or the inverse of f of x. So this is the first part. Now it says state what the independent and dependent variables represent. So the independent variable again is x here. Now initially x represented the altitude in thousands of feet. F of x represents the temperature. Remember, with inverses, these switch. So now x is the temperature in degrees Fahrenheit. And the inverse of f of x is the altitude in thousands of feet. So the independent and dependent switch when we take the inverse. So then in part B it says if the temperature outside a weather balloon is negative 18 degrees Fahrenheit, what is the altitude of the weather balloon? Well, all we have to do here is go ahead and substitute in negative 18 for our variable for x, because now x in this inverse equation represents the temperature. And we can do this in the calculator. So negative 2 divided by 7 times negative 18 plus 118 divided by 7. And this would be the altitude in thousands of feet, so approximately 22,000 feet. Or not approximately, but exactly 22,000 feet would be the altitude. So when you take the inverse, make sure that you realize that you are switching independent and dependent variables. Let's go ahead and take a look at number 32. 32, 33, 34, and 35 all work with exponential and logarithmic equations in terms of um, business applications. So our finance type questions that we had, that this was the beginning of our online assessment work. So let's go ahead and take a look at 32. It says Larry came up a little short one month as bills were due and had to take out a title loan on his car at Check Cashers Incorporated. He borrowed $262 and 3 weeks later paid off the note for $297.50. What was the annual interest rate on his loan? So this is a simple interest loan. So the interest is the principal times the rate times time. It's simple interest because it's a one-time fee. He borrowed it for $260 and he paid it back for $297.50. So the interest here would be the difference that he borrowed and what he had to pay back. So the interest here is the $37.50. The principal of the loan was the initial amount, what he borrowed, $260. The interest rate we don't know. So that's what we're trying to find. What's the annual interest rate? Because it says annual interest rate, the time is going to be out of a year. So this is a weekly period that we're talking about here. 3 weeks he had the loan, so 3 out of 52 weeks was the time period in which he owned, if we're again talking about annual interest. So what we can do here is we can solve for R. So first I would divide by 260 on both sides. So I'll round that answer when I write it down, but I'm not going to round it in the calculator. And then I would divide by 3 over 52 or multiply by the reciprocal. And so the rate is 2.5. Now remember, this is a decimal approximation of a percentage. So as a percent, this is a 250% annual interest rate. So this is an astronomical interest rate. Let's go ahead and put it down that it's 250% annually. So the short-time loan, though he may have needed the money, in terms of an annual rate, really was a steep price. Let's take a look at 33. How long would it take a $5,000 investment to double if invested at a rate of 9.25% compounded daily? So this is a compound interest question. So the equation for compounded interest at a varying time length is the amount A is equal to the principal times 1 plus the quantity of 1 plus the rate divided by the n to the nt power. And this is where n is the number of times that it's going to be compounded in the period. So if we want to know how long it would take for a $5,000 investment to double, we want this to double. So we have a principal of 5,000, but we want to end up with 10,000. And this is times 1 plus, now my rate here is in percent, so I want to make sure I change that to a decimal, 0.0925, divided by n, the number of time that it's going to be compounded. If it's daily, that's 365, and this would be 306 to the 365t power. So what I need to do here is I need to solve for t. So the first thing that I'm going to do is divide by 5,000. And so 10,000 divided by 5,000, don't really need a calculator there, it's 2. So this is 2 times, I'm going to go ahead and simplify what's in parentheses, just so it's not so much to write. So 1 plus 0.0925 divided by 365. And I'm going to write this down as just 1. Now I'm going to leave that number in my calculator because we're going to need that number later. So I'll write this as 1 to the 365t power. But again, I'm not rounding that number. I'm going to leave it in my calculator. Remember to get t out of the exponent. To get t out of the exponent, we need to use logarithms. Okay, so there's a couple of different ways that we can do this. If we're going to do this algebraically, and actually we'll just go ahead and do it algebraically. If you want to do this graphically, if it doesn't tell you you have to do it algebraically, you can do it graphically. But for right now, I'll just go through the algebraic process because that's a little bit more difficult. What I need to do here is get rid of the exponential function. So I want to use a logarithm with the same base. So what this would end up being is essentially log base approximately 1. Again, it's not exactly 1 of 2 equal to 365t. Well, if I want to evaluate this in my calculator, I can use the change of base formula. So I can do log of 2 divided by log of this number. So how I can get that is push second and the negative button, and that's going to take my previous answer and put it in there. And so this is roughly 2,735.47 equal to 365t. Again, I'm going to round it writing down, but I'm not rounding it into the calculator. Now I can divide both sides by 365. So t is approximately 7.49. And so I'm going to round at this point. At the very end, we'll go ahead and round. So it says, how long would it take for the investment to double? Approximately 7.49 years. Let's go ahead and take a look at problem number 34. As part of a lab experiment, Lumada needs to grow a culture of 200,000 bacteria, which are known to double in number in 12 hours. If he begins with 1,000 bacteria, find the growth rate and how many hours it takes for the culture to produce the 200,000 bacteria. So remember, this is a exponential growth problem, and what it tells us is that the bacteria double in 12 hours. So if we want to know the hourly growth rate, that's what growth rate is talking about, the hourly growth rate, we could take R to the 12th power, R to the time period that it's going to take. And what happens to the cultures in that time? Well, it becomes 200%. It doubles, becomes 200%, which would be 2. So what I can do to find the hourly growth rate now to solve for R is I'm going to take the 12th root. So in my calculator, I'm going to push 12, hit the math button, and then use this option number 5. I'm going to take the 12th root of 2. And this is the hourly growth rate. So the hourly growth rate, I'll round it when I write it, but again, I'm going to use this later. The hourly growth rate is approximately 1 point. Actually, let's carry it out to 4 decimals here. So approximately 1.05. Maybe let's carry it out to 4 decimals here. 0.0594. The reason that I want to carry it out to 4 decimals is because this is the decimal that represents growth or decay. Remember, anything greater than 1 is growth. So this is actually growing at a rate. So the growth rate is actually 5.94% per hour. So anything greater than 1 is a growth, anything less than 1 is a decay, and that difference is going to be the rate at which it's growing. So if I took this number and I subtracted 1, this gives me the growth here, and the growth is going to be 5.94%. Now I'm going to just add back 1, so I have that number in my calculator. Now, we want to also find how many hours it takes for the culture to produce 200,000 bacteria. Now, remember, for a growth, if we want to do an exponential growth, if we want an amount, it's going to be the initial amount, or the principal, times the rate to the t power. So we'll just use the same letters I had before. I may have used different letters in the notes, but use the same letters I had before. This is not compounding, it's just an exponential growth. So the amount that we want is 200,000. We want to produce 200,000 bacteria. The amount that we're starting with is 1,000 bacteria. The rate is going to be 1.0594 approximately. Again, we're using this number 1.0594 to show that it is growth because it's greater than 1. We want to find how many hours it's going to take, so we're going to solve for t. So the first thing that I'm going to do is take 200,000 divided by 1,000. So this is 200 equals 1.0594 to the t power. Again, we're going to use logarithms here. So I'm going to take a logarithm of both sides with the base 1.0594. And that's going to get rid of the exponential equation and get t by itself. So now I can go ahead and do this calculation. So I can do the logarithm using the change of base formula of 200 divided by the logarithm of this value that I still have in my calculator. And it's going to take approximately 91.73 hours to reach 200,000 bacteria. In problem 35, it says Valence wants to build an addition to his home outside Madrid, Spain, so that he may watch over and help out his parents in their old age. He hopes to have 20,000 euros to put aside for this purpose within 5 years. If he invests 12,500 euros in an account paying 8.6% interest compounded continuously, will he meet his 5-year goal? If not, find the minimum rate of interest that will enable him to meet his 5-year goal. So we've got another interest equation here, but this time it is interest that is compounded continuously. So our equation for interest that compounds continuously is a little bit different. The amount that we're looking for is equal to the principal times e to the RT power. So this is any time that it's compounded continuously, so that word is key there. So what he needs the amount of $20,000, or sorry, 20,000 euros. He's in Spain. He has 12,500 euros. He knows that the rate that it's going to have is 8.6%. So we could find out if this is going to be enough by putting in 8.6% and finding out what the amount is going to be. Instead, I'm going to figure out what rate he needs. So I'm going to go ahead and leave the rate as a variable, R. And he wants to do this over 5 years. So T is 5. So I'm going to solve for R to figure out what the rate needs to be. If it's less than 8.6%, then he's good to go. If it's not, he knows that he's going to need to find some additional funds. So the first thing that we want to do here is divide both sides by 12,500. So 1.6, this isn't rounded, so we'll leave that as 1.6. Now I need to get rid of this exponential equation. So again, we're going to use a logarithm with base E. We saw some examples earlier of that as a natural log. So the natural log of 1.6, I'll go ahead and just type this into the calculator, but then realize that we do need to divide by 5 here. So the rate is 0.0940. So the rate that he's going to need is going to have to be actually greater than 9.4%. So it's going to have to be, this is ever so slightly greater, but the rate that he's going to need has to be greater than, if we turn this decimal into a percentage, greater than 9.4%. Moving on, 36. So now we are getting out of that financial section and we are getting back into application problems, this time back into dealing with systems of equations. So problem 36 is a more basic system of equation. It says, at a recent production, the local theater bought in total $30,495 in revenue. If adult tickets were $9 and children's tickets were $6.50, how many tickets of each type were sold if 3,800 tickets were sold in total? So what we have here is we need to assign some variables. Let's say X equals the number of, I'm just going to use CT for children's tickets. And then let's let Y equal the number of AT for adults tickets. You can use any variables you want, but let's just use X and Y for this example. So what we know is that 3,800 tickets were sold. So whatever the adults tickets were and whatever the children's tickets were, if we add those together, it's 3,800. Now also realize that they had a revenue of $30,495. So revenue comes by selling adults tickets at $9 a piece and children's tickets at $6.50 a piece. So my other equation here is going to relate to revenue. So 9 times, or let's go with, just to keep the order the same, let's go with 6.5 times X, that's my children's tickets, plus 9 times Y, that's my adult tickets, is equal to 30,495. So now what I have is a system of equations. So I can solve this system of equations. If it doesn't tell us we have to do it algebraically, if you want to do this graphically, that is definitely okay. I'm going to walk through how to do this algebraically. So if I want to solve, I'm going to solve this by substitution. I'm going to get y by itself for the first equation. So I'm going to subtract x from both sides. Then I can take that value and substitute it into the second equation. So this would be 6.5x plus 9 times 3,800 minus x equal to 30,495. So if I take 3,800 times 9, that's going to give me 34,200. If I take 9 times negative x, that's going to give me negative 9x. So 6.5x minus 9x would be negative 2.5x. So negative 2.5x plus 34,200 equals 30,495. So I need to go ahead and take 34,200 and subtract that from both sides. So now I get negative 2.5x equals 3705, negative 3705, and I can divide by negative 2.5. So x equals 1482. Then I could go ahead and solve for y by substituting here. So I'll just do that in the calculator. 3,800 minus 1,482. Y equals 2318. So what I know here is 1,482 children's tickets were sold and 2,318 adult tickets were sold. So if we do have a problem with some context, make sure that you go ahead and put your answer back into that context. So don't just leave it as x equals and y equals. We want to explain what those variables x and y are. Problem 37 is also a system of equations. So it says on a recent camping trip, it took Molly and Sharon 2 hours to row 4 miles upstream to their campsite. On the return trip downstream, they completed the same distance in 30 minutes. So basically what we have here is, remember some basic formulas that you probably used in Algebra 1, maybe in science. Distance equals rate times time. So in both scenarios, they are rowing the same distance. What we have here is that as they are rowing, let's say this is the stream, as they're rowing upstream, the current is going this way, and they are going that way. So let's let x equal the speed of Sharon and Molly as they row. Let's let y equal the speed of the current. So as they row, the distance, whatever the distance is, we don't know, or sorry, we do know what the distance is. It's 4 miles. Whatever the distance is, 4 miles, it's the rate of them going one direction and the current working the other direction. So their rate would be the speed of Molly and Sharon minus the speed of the current times time. It takes them 2 hours to complete this. So if I simplify this first equation, 4 equals 2x minus 2y. Now, on the return trip, they're going downstream. So this time the water's flowing this direction. They're rowing this direction. So their speed and the speed of the water is working together to create a faster rate. So on the return trip, it's still going to be 4 miles, but this time, oops, sorry, it's still going to be 4 miles on the return trip, but this time they're working together, x plus y. And it takes half an hour. So then 4 equals 1/2 x plus 1/2 y. And this is my system of equations. So in A, I want to solve for the speed of the current, which would be technically y here. So I'll solve for the variables first and then answer the questions. I'm going to go ahead and use elimination here. So I'm going to double the second equation and then add the two equations together. So 4 equals 2x minus 2y is unchanged. 8 equals x. Sorry, I'm not going to double. I'm going to have to multiply these by 4. So 16 equals 2x plus 2y. So I'll multiply this entire equation by 4 there. And then I can combine the two equations to eliminate. So 20 equals 4x, divide by 4. So 5 equals x. Then I can go ahead and substitute back into the equations, in either of the equations. So I'll go ahead and substitute back there. So 4 equals 10. 2 times 5 minus 2y. So negative 6 equals negative 2y. Y equals 3. So in part A it said find the speed of the current. So the current is traveling 3 miles per hour. Find the speed of Molly and Sharon. So Sharon and Molly together were rowing at a speed of 5 miles per hour had there been nothing helping them or nothing working against them. And so we have reached the conclusion of the end of the year assessment study guide. Okay, so this is an example of every single problem in the study guide. Again, if you had some questions that were not answered in this part of the study guide, they would have been answered in part one. So if you need some more questions answered, go ahead and take a look at part one. You'll have some more answers there. If you still have some questions over these problems, feel free to let me know. You can shoot me an email. I will also be on Zoom in the times that are posted on Google Classroom. You can drop into any of those sessions at any time, and we can work through the problems that you may be having. Thank you guys for tuning in. Have a great day.